Welcome back, mathematicians. In this video, we are going to look at the vertical compression or stretch transformation. So in general, this is represented as y is equal to a times f of x, where f of x is your parent or basic function. A then is the factor that you will multiply all the outputs of or for that parent or basic function, resulting in new outputs. A, or the value of a, will determine whether this is a compression or a stretch. So if a is greater than 1, then the transformation represents a vertical stretch. If, however, a is less than 1 but greater than 0, then it represents a vertical compression. So in our example, we have f of x is equal to 2 times the absolute value of x. Our first goal should be to graph the parent function. The parent function is stripped of all transformations. In this case, that would be the absolute value of x. Making a table to represent my ordered pairs that I will plot, I have negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. Plotting this on the coordinate plane, I get the graph of a v. Now I'm going to identify the value a and what that represents in terms of my transformation. A in this case is positive 2, which means that it's going to represent a vertical stretch by a factor of 2. How we will graph this then is multiply all outputs or y coordinates by a factor of 2, resulting in my stretched graph. So 0, 0 will remain the same. 1, 1 becomes 1, 2. 2, 2 becomes 2, 4. Then we also have negative 1, 2 and negative 2, 4. So then this absolute value function has been stretched by a factor of 2. Our second example is g of x is equal to 1/4 times x squared. Again, I'm going to represent or graph the basic or parent function, which is y is equal to x squared. Making a table of values that I will plot for this parent or basic function, I will have negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. Plotting this, I get a U-shaped curve, which we call a parabola. And now I'm going to identify the transformation, what it represents, and also apply it to this parent function. Since a is equal to 1/4 and it's between 0 and 1, that represents a vertical compression by a factor of 1/4. This now means I'm going to take all my y coordinates from the parent function and multiply it by a factor of 1/4. So 0, 0 remains the same. 1, 1, however, becomes 1, 1/4, and then 2, 4 becomes 1, 1. Repeat it on the other side, and we get negative 1, 1/4, and negative 2, 1. And so this is what the graph looks like when it's been compressed vertically by a factor of 1/4. All right, guys, good luck.